Queue data structure. A queue is a useful data structure in programming. It operates on the principle of first in, first out, similar to a ticket queue outside a cinema hall. The item that enters the queue first is the one that gets processed and removed first. In the given image, as 1 was added to the queue before 2, it is also the first to be removed, following the FIFO rule. In programming, adding items to the queue is called enqueue, and removing items is called dequeue. We can implement a queue in various programming languages like C, C++, Java, Python, or C#, and the specifications remain mostly consistent. Basic operations of queue. A queue is an abstract data structure that supports the following operations. Enqueue, adding an element to the end of the queue. Dequeue, removing an element from the front of the queue. Isempty, checking if the queue is empty. Isfull, checking if the queue is full. Peek, getting the value of the element at the front of the queue without removing it. Working of queue. The queue operations work as follows. We use 2 pointers, front and rear. Front tracks the first element of the queue. Rear tracks the last element of the queue. Initially, we set the value of front and rear to -1. Enqueue operation. The enqueue operations are as follows. To check if the queue is full. For the first element, we set the value of front to 0. We increase the rear index by 1. We add the new element to the position pointed to by rear. Dequeue operation. The remaining queue operations are as follows. To check if the queue is empty. To return the value pointed by front. To increase the front index by 1. To reset the values of front and rear to -1 when there is only one element left in the queue. Limitations of queue. After performing some enqueuing and dequeuing operations, as shown in the image below, the size of the queue has decreased. Once the rear reaches the last index, we can utilize the empty spaces at indexes 0 and 1 only when the queue is reset. To achieve this, a modified queue called the circular queue is implemented, which allows continuous use of the available space in a circular manner. Complexity analysis. The complexity of enqueue and dequeue operations in a queue implemented using an array is big O of 1, meaning they have constant time complexity. However, in Python, if you use poppin to remove an element from the queue at a specific position n, the complexity may be big O of n, where n is the number of elements in the queue, depending on the position of the item to be popped. Applications of queue. Queues have various applications in programming and computer systems. CPU scheduling and disk scheduling use queues to manage tasks and data access efficiently. When data is transferred asynchronously between 2 processes, queues are used for synchronization. Examples include I/O buffers, pipes, and file I/O. Real-time systems use queues to handle interrupts and prioritize tasks. Call center phone systems use queues to hold incoming calls in an orderly manner, ensuring fair handling and efficient service.